PVC Carlon is generally not permitted for data installations within commercial buildings. This restriction is due to several factors primarily related to fire safety and building codes. Data cables often generate heat, and in the event of a fire, PVC, or polyvinyl chloride, conduit can release toxic fumes and contribute to the spread of flames. Building codes typically mandate the use of materials that are more fire-resistant and produce less smoke in such situations. Acceptable alternatives for data cabling in commercial buildings include firstly, electrical metallic tubing, commonly known as EMT, which is a thin-walled steel conduit that provides excellent physical protection for cables and is non-combustible. Secondly, rigid metal conduit (RNC), which is a thicker, heavier-gauge steel conduit offering superior protection against physical damage and is also non-combustible. Thirdly, flexible metal conduit (FMC), which is a spiral wound metal conduit that allows for flexibility in installation while still providing a degree of protection. Fourthly, cable trays, which are open support systems that can carry a large number of cables and facilitate easy access for maintenance and modifications. These alternatives are generally preferred because they meet stricter fire safety standards and provide better physical protection for the data cables. Using the correct type of conduit is essential for ensuring the safety of the building occupants and the integrity of the data network. Always consult local building codes and regulations, as these can vary depending on the jurisdiction. It is also advisable to consult with a qualified electrician or data cabling specialist to ensure that the installation meets all applicable standards and requirements. The choice of conduit material depends on several factors, including the type of cabling, the environment in which it will be installed, and the specific requirements of the local building codes. For example, in areas where there is a risk of physical damage to the cables, RNC may be the best choice. In areas where flexibility is required, FMC may be more suitable. Cable trays are often used in large commercial buildings where there are a large number of cables to be run. In addition to fire safety and physical protection, it is also important to consider the grounding requirements for data cabling. Proper grounding helps to prevent electrical noise and interference, which can degrade the performance of the data network. Metal conduits such as EMT and RNC can provide an effective grounding path, while non-metallic conduits such as PVC do not. Therefore, when using non-metallic conduits, it is necessary to install a separate grounding conductor. The National Electrical Code, or NEC, provides detailed requirements for the installation of data cabling and grounding. It is essential to follow these requirements to ensure a safe and reliable installation. Some specific sections of the NEC that are relevant to data cabling include Article 725, which covers Class 1, Class 2, and Class 3 remote control, signaling, and power limited circuits, Article 800, which covers communications circuits, and Article 820, which covers coaxial cable. These articles provide requirements for wiring methods, overcurrent protection, grounding, and other aspects of data cabling installations. When installing data cabling in a commercial building, it is important to obtain the necessary permits and inspections. This will help to ensure that the installation meets all applicable codes and regulations. It is also important to keep accurate records of the installation, including the type of cabling used, the routing of the cables, and the grounding connections. These records can be helpful for troubleshooting and maintenance in the future. Furthermore, consider the potential for electromagnetic interference, or ME, when routing data cables. EMI can be caused by nearby electrical equipment such as motors, transformers, and fluorescent lights. To minimize EMI, data cables should be kept away from these sources of interference. Shielded cables can also be used to reduce the EMI. In addition to the choice of conduit and cabling, the installation practices are also important. Cables should be properly supported and secured to prevent them from sagging or becoming damaged. Cables should also be neatly organized and labeled to facilitate troubleshooting and maintenance. When terminating data cables, it is important to use the correct connectors and tools. The connectors should be properly crimped or punched down to ensure a reliable connection. The cable should also be tested to verify that they meet the required performance specifications. Regular inspections and maintenance of data cabling installations are essential to ensure continued performance and safety. Cables should be inspected for damage, and connectors should be checked for loose connections. Any damaged or defective component should be replaced promptly. By following these guidelines, it is possible to ensure that data cabling installations in commercial buildings are safe, reliable, and compliant with all applicable codes and regulations. Remember to prioritize fire safety and adhere to local building codes to protect building occupants and infrastructure. Always consult with qualified professionals for expert guidance on specific installation requirements and best practices. When discussing fire safety, it's vital to understand the different types of cable and conduit that are available and their respective fire ratings. Plenum-rated cables, for instance, are designed to be installed in plenum spaces, which are areas used for air circulation, such as above suspended ceilings or under raised floors. These cables are made with materials that produce minimal smoke and toxic fumes in the event of a fire. Non-plenum rated cables should not be used in plenum spaces, as they can contribute to the spread of fire and release harmful substances. The National Fire Protection Association, or NFPA, publishes standards that provide detailed requirements for fire safety in buildings. NFPA 70, the National Electrical Code, is the most widely adopted electrical code in the United States. It provides requirements for the installation of electrical wiring and equipment, including data cabling. NFPA 101, the Life Safety Code, provides requirements for the protection of life from fire and other hazards in buildings. These standards should be consulted when designing and installing data cabling systems in commercial buildings. In addition to fire safety, it's also important to consider the environmental conditions in which the data cabling will be installed. In areas where there is moisture, humidity, or corrosive chemicals, it may be necessary to use cables and conduits that are specifically designed for these conditions. For example, stainless steel conduit may be used in areas where there is a risk of corrosion. Furthermore, consider the bandwidth requirements of the data network when selecting cabling. Different types of cables have different bandwidth capabilities. For example, Category 5 E-cables can support data rates of up to 1 gigabit per second, while Category 6 cables can support data rates of up to 10 gigabits per second. Choice of cable should be based on the current and future bandwidth requirements of the network. When installing data cabling, it is important to follow industry best practices for cable management. Cables should be neatly bundled and secured to prevent them from becoming tangled or damaged. Cables should also be labeled to identify their purpose and destination. Proper cable management makes it easier to troubleshoot and maintain the data network. In addition to the technical aspects of data cabling, it's also important to consider the aesthetic appearance of the installation. Cables should be routed in a neat and orderly manner, and they should be concealed whenever possible. This can help to improve the overall appearance of the building. Finally, remember that data cabling is an important part of the overall building infrastructure. A well-designed and properly installed data cabling system can provide a reliable and efficient platform for communication and collaboration. By following the guidelines outlined in this discussion, it is possible to ensure that data cabling installations in commercial buildings are safe, reliable, and aesthetically pleasing. Always prioritize safety, adhere to local codes, and consult with qualified professionals to ensure the best possible results. To recap, the prohibition of PVC Carlon for data installations in commercial buildings stems from concerns about fire safety, code compliance, and the potential for toxic fumes in the event of a fire. Instead, alternatives like EMT, RMC, FMC, and cable trays are recommended due to their superior fire resistance and physical protection. The NEC and other relevant standards provide detailed requirements for data cabling installations, covering aspects such as wiring methods, grounding, and overcurrent protection. Proper installation practices, including cable management and termination techniques, are crucial for ensuring the reliability and performance of the data network. Regular inspections and maintenance are also essential for identifying and addressing any potential problems. By adhering to these guidelines and consulting with qualified professionals, it is possible to create a safe, efficient, and compliant data cabling system for commercial buildings. Remember to prioritize safety, follow local codes, and stay informed about the latest industry best practices. The choice of cabling and conduit should also consider the environmental conditions, bandwidth requirements, and potential for electromagnetic interference. Furthermore, attention to detail in cable management and aesthetic appearance can enhance the overall quality of the installation. Ultimately, a well-designed and properly installed data cabling system is a valuable asset that can support the communication and collaboration needs of a commercial building for many years to come.